Okay, I'm having a look at the Maths Methods external paper from 2023, looking at the multi-choice questions from paper 2, so the Tech Active paper. So question number 1. Now when I look at question number 1, I'm going to put that into my calculator, and because I've got the function of sine of 3x and I want to find the derivative or the gradient at pi on 8. So need to have my calculator in radians because of that pi. I'm going to pop my function in there. So I'm going to put my sine of 3x in. I'm going to hit graph. Might have to change my window there. So I'll go my standard -10, 10. And there's my graph. I just need to make sure I'm going to, I have the pi on 8 will be visible on there. So then I'm going to use my second trace. I'm going to use the derivative there because this is Tech Actives and it's multi-choice, so I may as well do it as quickly as possible. And I just want to find out when pi on 8, when the x is equal to pi on 8. And up here I can see that it is equal to 1.1480486. So I look at my multi-choice, and so that means it's going to be B, 1.148 is my answer. So then for question 2. Now when I look at question 2, I'm thinking this could actually just be a tech-free question. I don't know why it wasn't in the tech-free paper because it doesn't require any tech. They give you the fractions there. So I'm looking at the probability of hitting a bullseye on a standard dashboard is 1 in 1250. So that means my fraction for that is going to be 1 over 1250 of hitting it. That means my chance of not hitting it is then going to be 1249 on 1250. So they're my two probabilities there. I want the probability of hitting exactly once in 10 attempts. So my probability of hitting is going to be raised to a power of 1. And that means the probability that I'm not hitting it means that's going to be 9 because 10 take away 1 is 9. Then I want those combinations to go out the front. So then I'm looking for the one that has, obviously I don't want 9 there. I want out of 10 attempts and 1 success. So then I look down here and that gives me C, that has the bits that I need there. So I could have automatically ruled out these first two and then decided between those to make it a little bit quicker. Okay, question 3 we're looking at is in a certain normal distribution curve, 95% of the area lies between the values of 50.32 and 113.68, and the mean of this distribution is 82. Determine the standard deviation. Now, initially when I looked at this question, I went like a really easy way of doing it and saying, okay, well 95% of the area, I know that that's 2 standard deviations approximately. So I can just go 113.68, take 82 and divide by 2. And that gave me 15.8. And so I looked over to the side and went, oh, well, that's none of the options. I'll go with A because that's the closest to it. And then had to think about it as to why I didn't get the exact answer. I went, okay, well, if I looked at it differently and went, well, 95%, if I changed that to a Z score, it would be 1.96. And then I could use my Z is equal to X minus the mean over standard deviation and solve that way. So then that means I would have the 1.96 is equal to 113.68. And I could have easily have done the 50.32. It doesn't matter which one I choose. Minus 82 over my standard deviation. So then I would get that 31.6, which is that top part of it, divide by 1.96, and that would give me that 16.16 as my answer. So doing that the long way. Depends how you feel in the exam. If you want to just do the approximate and choose from there, could be a bit quicker. Okay, question 4. Question 4, we have been given the displacement and we want to know about the acceleration. Now it's a fairly easy equation, so we can just do that. If our displacement is the e to the 0.5 t minus 1, then our velocity is going to be equal to 0.5 e to the 0.5 t. And then when we do our acceleration, we will make that 0.25 e to 0.5 t, and then we're just subbing in our t equals 4. 0.5 times 4 is just 2, and then we can work that out on our calculator, and we get 1.847. So over here we've got 1.847 as an option, which is D. Question 5. Solving ln x plus ln of 3.7 is equal to ln of 9.25. So firstly I'm going to bring those two together and make that ln of, when we are adding, that will multiply those. So 3.7x is equal to ln of 9.25. Now because we've got the ln on both sides, we can then say that the 3.7x must be equal to 9.25. So x is going to equal 9.25 over 3, which gives us 2.5, which is our answer C. For question 6, initially it does look a little bit weird because we've got the a's there, but we can just go with that. So not worrying too much about there being a's. First we've got our 1 on x plus a. We know the integral of that is going to be ln of x plus a. And we're going to do that between a and 5a. So then we're to sub that in. So we get ln of, so we're subbing in the 5a first, so 5a plus a. And take away ln of a plus a. So that means we get ln of 6a, take away ln of 2a. So when we bring them together, we will get ln of 6a on 2a, which is ln of 3. When we work out what ln of 3 is equal to, we get 1.0986, which is our option D. Question 7. The distribution of a certain sample proportion has a mean of 0.7 and a standard deviation of 0.2. We want to find the sample size. So we can use our rule where we have our standard deviation and assuming that that proportion one is our mean of 0.7 and we've got the 0.02 there. So we've got square root of 0.7 times, and then 1 take 0.7 is going to be 0.3 over our n. That's going to give, then we'll do the square of that, of the 0.02. Then we'll make them switch places, and so we get our n is equal to 525, which is A. Question 8. We've got the number of koalas in a conservation park modelled by this. Then we've got, there were 20 koalas in the park when it opened. We don't really need that. Determine the approximate rate of change in the number of koalas when t equals 3. So this is one where I'm just going to pop that into my calculator again, like I did for, I think it was question 1. Then we've got our y equals, we're going to pop in our 15 ln of 7x plus 1, and we'll graph that. I'm just going to change my window to go up a bit higher on my y. There we've got our nice little curve, and then if we use that same derivative function there, we can find that rate of change because that's when the gradient at that point. We want when it's equal to 3, and we get 4.772. Now we wanted approximate, so we got the answer of 4.772. We just wanted the approximate, so that will be 5 there. Obviously, if you were doing approximate rate of change, you could have subbed in t equals 2.9, t equals 3.1, find the average between those, or 2 and 4, find the average between it. I think this is the quicker way to do it, especially for a tech active paper. For question 9, we've got a question where we need to do determine the expression for A. We've got the derivative there, so obviously we want to do our product rule here, or product and chain in one, to find the derivative and then simplify, factorize to get what that bit is at the front. So obviously a bit of a longer question. Time-wise, if you are concerned about time, I would probably leave some of these longer type questions and come back to them at the end because they're only worth 1 mark each, because this one's a little bit longer to do. So we've got u is equal to e to the 3x. We've got our v is equal to x plus 1 squared. Our u dash is going to be 3e to the 3x. And our v dash is going to be, and it's obviously a chain rule, but a simple chain rule one, so we're just bringing that 2 down. And if we were multiplying, we'd be multiplying by the derivative of the inside, but that is 1 anyway, so that's what our answer is there. Bringing them together, we get u dash v plus v dash u. Obviously no working needed for multiple choice questions. We've got 3e to the 3x times x plus 1 squared, and we're adding to that 2 outside of x plus 1 times e to the 3x. So looking at that, we have that common factor of e to the 3x there and the x plus 1. So we're able to take that to the front. And then we're left with 3 outside of x plus 1, because we've taken one of those brackets out, plus 2, because we've taken that bracket out there as well. So we've taken that and one of those. So then we're left with, in this bracket, if we expand that out, that's 3x plus 3 plus 2. So 3 plus 2 is going to be 5. So in that bracket we would have 3x plus 5. And so our answer would be A. Question number 10, last one on the paper. We have got a list of results to compare. So we're obviously wanting to use the z-scores to compare there. So our z is equal to x minus the mean over standard deviation. Now, to make sure we're not wasting any unnecessary time, having a quick look at the student's result versus the class mean. Okay, so we've got 77 versus 62, so they're above the mean, 74 above 55, 70, 61, 82, 73. So they've all scored above what the class mean was. So that's good, we don't have to rule out any that were under. So then we just go through and work out those z-scores there. So we're going to go 77 take 62 divided by 22 there, gives us 0.68. We'll do our 74 take 55 divided by 25, gives us 0.76. 70 take 61 divided by 15 gives us 0.6, and 82 divided by 73, 82 take away 73 divided by 20 gives us 0.45. So looking at then at those numbers, the highest number is that second one, which is B.